August 1878, Bristol Harbour, coal smoke and salt water hang over Prince's Wharf as a crowd of dock workers, port commissioners, and curious passers-by gathers around something none of them has seen before. It stands 40 feet above the quayside, curved like a great iron question mark against the gray Bristol sky. Inside, a riveted cab of wrought iron sits a vertical boiler, pressurized, quietly hissing. A chain hangs from the jib, taut and ready. Test loads of sandbags and steel wait on the cobblestones below. The boiler fires, the chain tightens, the 35-ton load rises clean and smooth into the air above the dock. Nothing buckles, nothing screams, nothing fails. The men watching have built things before that broke on first testing. Bridges that sagged, boilers that burst, engines that shook themselves apart within a season. This machine does none of those things. It simply works. Precisely, powerfully, without complaint. 146 years later, on the same quayside, under the same Bristol sky, it still does. Bristol in the 1870s was a harbor in quiet crisis. The Industrial Revolution had transformed what British ships carried. The cargoes were no longer wool and wine. They were boilers, steam engines, iron machine parts, the raw organs of industrialization itself. Objects that could weigh 10, 15, 20 tons each. Iron-hulled ships had grown taller and deeper. And Bristol's entire fleet of 17 quayside cranes could not lift a single one of these loads. The maximum capacity of any crane on the harbor was 3 tons, the weight of a carriage and 2 large horses. The commissioners had already invested heavily in a railway line running along the quay. Steel rails right to the water's edge, ready to receive the freight of the modern world. Useless. Every heavy cargo sat in the hold, unreachable. As Bristol was in danger of losing the trade it depended on. In 1875, they placed an order. The man behind the design had died the year before, in 1874, at 85 years old. Sir William Fairbairn, born in Kelso in 1789, son of a Scottish farmer, had spent his lifetime reshaping what iron could do. He had designed the box girder tubes of the Britannia Bridge with Robert Stephenson. He had built iron ships at Millwall on the Thames, and he had conducted the first systematic British research into metal fatigue, raising and lowering 3 tons onto an iron cylinder 3 million times until it fractured. Early proof that material failure under repeated stress was predictable, measurable, and therefore preventable. And in 1850, he had patented a crane, not just any crane, one with a curved jib. The problem with lifting heavy cargo from a deep-hulled iron ship was simple and maddening. Straight cranes could not reach over the high gunwales and down into the hold. Fairbairn's solution was to arc the jib, to give it a banana shape that swept over the ship's side and plunged below deck level. The jib was not a single iron bar. It was a hollow box girder built from riveted wrought iron plates with tension on the outer convex face and compression on the inner face. The geometry carried the load the way a bridge carries traffic, by understanding where the forces lived and letting the structure breathe around them. The Bristol commissioners gave the contract to Stothard and Pitt-a-Bath, a local engineering firm already supplying dock machinery across the British Empire. 3 years of work followed. masonry foundations dug 25 feet below the quayside, 120 tons of iron assembled above them. A vertical boiler enclosed within a riveted cab, running at 100 pounds per square inch. 2 twin-cylinder steam engines, one to slew the crane, turning the entire machine on its axis, and a larger one to drive the winding drums, which could run at 4 separate speeds from cautious to confident. The jib reached 35 feet out over the water. The whole structure stood 40 feet high and was designed to lift exactly that, 35 tons per lift. The cost, 3,600 pounds for the machinery plus foundations in 1878. For a machine built to outlast the men who built it. And then, almost immediately, the world moved on. This is the part of the crane story that the plaques on its base do not always mention. The uncomfortable truth is that the Bristol Fairbairn steam crane was, for most of its working life, almost never used. By 1890, it had operated for just 16 days in an entire year. The port accounts recorded a net profit for that 12-month period of 11 shillings and sixpence. Not pounds, shillings. Ships had grown taller since 1878, and the jib, fixed at 40 feet, could no longer reach far enough into their deeper holds to do the work it was designed for. The machine that had cost the harbor commissioners a small fortune to solve their heaviest problem now stood idle, month after month, cold and silent on Prince's Wharf. In 1892, hydraulic cranes arrived, faster, more flexible, powered from the central pumping station at Underfall Yard. In 1906, electric cranes appeared on their own rail lines, mobile along the entire quay edge, able to reach any ship's hold on demand. Between April 1905 and April 1906, the Fairbairn steam crane made 0 lifts. None. It spent a full calendar year untouched, its boiler unfired, its chain slack. From 1903 to 1909, across 6 full years, it completed 143 lifts in total, roughly 2 per month. For a machine built to transform Bristol's capacity for heavy cargo, this was not the life its makers had imagined, and yet nobody demolished it. Nobody sent for the scrap merchants. It stood on the quayside and it waited. September 1939, the crane woke up. A landing craft flotilla unit took station at Prince's Wharf. Britain was at war, and someone, somewhere in the chaos of mobilization, had looked at the Bristol docks and realized that among all the electric and hydraulic machinery now crowding the waterfront, only one thing had the raw lifting capacity that the next few years would demand. Over 1,000 new assault landing craft, flat-bottomed steel boats built for beach landings in the Far East and the Pacific, arrived at Prince's Wharf on lorries. They needed to be unloaded, adapted, and launched. The only machine on the quay that could move them was 61 years old. More than 2,000 lifts in 3 years, unloading the lorries, launching the completed craft into Bristol Harbour, the same riveted iron jib, the same boiler, the same chain and drum assembly that had been built for the Victorian commercial dock trade, now placing steel landing boats into the water for a war that would partly be won or lost on the beaches they were designed to reach. No major structural failure, not one. The war ended, the docks declined. In 1973, the crane passed to Bristol City Museum. In 1976, It was designated a scheduled ancient monument, the last surviving operational Fairbairn steam crane on Earth. From 1988, it was restored to full working order and became the centerpiece of what is now the M. Shed Museum at Prince's Wharf. On festival days and bank holidays, the boiler is still lit. The pressure climbs to 100 pounds per square inch. The twin engines engage. The chain moves. People who have never thought about Victorian engineering walk around the base of the thing and look up, and something registers, not just admiration, but a kind of unsettlement. The recognition that this was built to last. And it did, and it does. The Bristol Fairbairn steam crane weighs 120 tons. It extends 25 feet below ground before it reaches solid stone. It was designed by a man who died before it was built, fabricated by craftsmen who knew they would never see its last day, tested in August of 1878 and found not wanting. It was commercially marginal for most of its life. It was vital to the war effort for 3 years. It has been standing on this quayside since before the motor car existed. Victorian engineers built with margins of safety not calculated in decades, but in generations. They built things designed to outlast themselves, because they believed in permanence at a time when permanence meant something, when a structure that failed cost lives and credibility and could not simply be replaced with a new model the following year. This crane is not a relic. It is not a museum piece that happens to still move. It is a demonstration, still running, of what happens when the people who build something actually believe it should last. 146 years. No major failure, not luck, not nostalgia. That is what it means to build something properly.